Okay, this is lesson 1.4, example 2. And here we're using induction to establish the summation of 4n minus 1 from I equals 1 to n, equaling n times 2n plus 1. So the first thing we need to do, part 1, is we need to let n equal 1. So from here, this will be some I equal 1 to, since n is 1, we put 1 there, 4n minus 1. And so that's going to be 4 times 1 minus 1 equals to the right side 1 times 2 times 1 plus 1. So 4 times 1 is 4, minus 1 is 3. So 2 times 1 is 2, plus 1 is 3. So 3 times 1 is going to be 3 equals 3. So part 1 checks. Okay, so that's establishing basically that 1 is an element of set S, if we call this set S. All right, so part 2, let n equal to k. So again, we do the same thing, put the same equation in here, but now I equal 1 to where n was, we put k. And so this is 4n minus 1 equals to so we're going to make this, we're trying to get this to equal n times 2n plus 1. All right, so this will be 4 times 1 minus 1 plus 4 times 2 minus 1 plus dot 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 4 times k minus 1, and that's going to equal this. So where n is, we put k in, and we put 2k plus 1 in there. All right, so from there, now we do part 3. And we get another paper for that because I'll only have enough. So part 3, we want to let n equal to k plus 1 this time. Okay, so this will be summation I equal 1 to k plus 1 for 4n minus 1 equal to n times 2n plus 1. So that's going to equal 4 times 1 minus 1 plus 4 times 1, or 2 rather, minus 1 plus dot 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 plus 4 times k minus 1 plus, now we have to do 4 and then times k plus 1, because that was k. Now the next one's going to be k plus 1 minus 1. And that's going to equal to, here we said k. So this is going to equal to k plus 1 times, I'm trying to squeeze all this in here, 2 times k plus 1 plus 1. So that's going to equal to k plus 1. So we distribute the 2, and it's 2k plus 2 plus 1. And so we get k plus 1 times 2k plus 3. So from here, we need to get the left side to match the right. So the thing to remember here is that this, all this, is equivalent to all this. It's the same. So therefore, we can take this part and set it and substitute k times 2k plus 1 in for this. Okay, so we can take, that means we can take k times 2k plus 1 plus, because that's this, plus that. And so we can go ahead and distribute the 4. 4k plus 4 minus 1. All right, so this will equal to, we can go ahead and distribute this k. So this will be 2k squared plus k plus, and then this will be 4k plus 3, and that equals the. So we need to combine like terms here. So this would be 2k squared, 1k plus 4k is 5k plus 3, and that's going to equal to k plus 1 times 2k plus 3. Okay, so here we can factor. So if we factor, and we put in our k, and we know our signs are going to be plus and a plus. Factors of 3 have to be 3 and 1. So factors of 2 have to be 2 and 1. So the only thing that we don't know is if 2 is here or here. So if we put 2 here, then that would be 2 times 3 is 6. 6 plus 1 is 7. So it's not that. So we have to put 2 here, 1 here. And so if we check it, right, 1k times 2k is 2k squared, 1 times 3 is 3k plus 1 is 2k, 3k plus 2k is 5k, 1 plus 3, so it checks. And so we get here k plus 1 times 2k plus 3, and both sides are equal, so we've established it checks. And that is all we have to do for that. All right, let me know if you have any questions.